So my talk today is called Squish Meets Structure, and it's about designing with language models, which is something I've been doing for the past 2 years. By language models, you hopefully know what I mean by now, but I mean things like GPT-4, ChatGPT, Anthropic's Claude, Llama. At this point, I think most of us are quite familiar with them, but I want to get a sense of everyone's experience. So can I get a show of hands of who has never used ChatGPT or any other kind of language model? That's pretty good. I had a lot of hands when I asked this in October of last year. Who regularly uses language models every day for their work? Okay, we think we've got almost majority. Who has worked on integrating a language model into a product, like you've built something with them? Yeah, that's pretty good. Yeah, I had literally like 2 hands at a conference in Germany in October, which was like shocking at the time. So I feel like we've kind of hit more popular mass with these things. There's obviously a lot of hype and noise and like outlandish predictions about whether these models might kill us or make us all unemployed. So I wrote this talk as a way to give a little bit of clear-headed guidance, a little bit of grounding of how to think about building with these models in a very practical way beyond like grand philosophical speculation. So a little context about me. My name is Maggie. I look like this on the internet. I'm a product designer for a company called Illicit. We use language models to help scientists and researchers speed up their work, and I will talk a lot more about that later. I'm also a very mediocre developer, meaning I try to build things, but then sometimes they don't work. I originally trained as a cultural anthropologist, which makes me look at this world of language models and programming through a very cultural lens. And I'm also what I call a tools for thought enthusiast, which means I'm very interested in building tools that advance our ability to think thoughts and reason well and research well. And this is kind of how I got interested in working with language models. So before I dive into talking about how to design with language models, I first want to cover what language models actually are. So to make a language model, you need an enormous volume of words. And if we look at the training data for something like OpenAI's GPT-3, which is like the most training data information we have, it came primarily from the web. So there are these 2 very large data sets called Common Crawl and text-to-web. And they are huge scrapes of the open web, and they include, of course, lots of stuff from Reddit, but also blog posts, news sites, pretty much anything we've made on user-generated social media for the past decade or 2. They also trained it on lots of books, like published books, and then they trained it on everything on Wikipedia, but that was still only 3% of the training data when you take all the text on Wikipedia and put it into this training set. So this is a huge training set. Most of the time, the companies don't release the training data models. We don't actually know what they were trained on, but we can assume GPT-4 built off this. Things like Llama have similar training sets to this. There's only so much text we even have in the world, and we've kind of used all we can to train the models we currently have. So what we do is we feed that data into a neural network, which is what creates the language model. And this neural network looks at how we structure words and sentences and looks at the relationships between them. So if you take a sentence like, your income tax is due by April 5th, the model is learning that the word tax often occurs near words like income and deadlines. If it looks at the word like mitochondria, it sees a lot of things about cellular processes and producing energy. Or if you took a sentence like, I love sausage rolls from Greg's, it learns that sausages often occur near rolls and Greg's. So the model is encoding what words tend to occur near other words and what order they go in. And we can think of this model as a kind of enormous space where each word is represented by a single point. This space is sometimes called latent space. And the position of each word gets represented by a very long string of numbers, which we call a vector, and this tells us its position in space. So if we look at the position of a word like tax, it's going to be spatially near words like forms, or loophole, or accountant. All of these words share similar aspects or properties, and that they are all related to governments and law and money. And because all of these words are represented by numbers, we can do fun maths with them. So if we take the vector for sausage, and we add the vector for German, we get bratwurst. If you add the vector for American, you get hot dog. If you add the vector for cooked, you get charcoal, and if you add the vector for less cooked, you get pig. So these are really interesting mathematical operations. We've essentially made a super advanced linguistic calculator. What we're doing here is moving around a map of human concepts that the model has learned from reading all of our language. So we have these kind of dimensions of like Americanness and Germanness and Cookedness that you can move a word like sausage around. And language models have thousands of these dimensions they've encoded words along. So GPT-4 has 12,388 dimensions. So we only ever think in 3 dimensions, right? But you can imagine 12,000 dimensions that you're moving words and concepts along. And these dimensions capture all kinds of subtle spectrums that are implicitly embedded in our language. We wouldn't be able to give names to many of these, but we can do for some. We can think about things as being formal or casual, or friendly or professional, or male and female, or big and small. We understand some of these oppositions, but there are ones the model understands that we couldn't even conceive of. And this is how we're able to use language models to do something like shift the tone of a sentence. If you say, make this sentence more professional, this is the kind of calculation you're doing to move that sentence. But this is exactly why these things are not just text generators. They have a fuzzy map of human concepts and understandings, and they have embedded within them all of our cultural, historical, scientific, and legal knowledge. They are definitely flawed maps because they are only as good as their training data. So these are maps of information available primarily on the English-speaking web. But they are maps worth exploring because they go far beyond just generating text. It's easier to see how this works in visual latent space. So this is a demo from my friend James Addison showing how you can like move a picture around an emotional map, and he's using the same kind of system to change the expression on this character. So now that we have these giant language calculators with all these embedded words, they can help us do lots of really interesting things. So one thing they can do is figure out the similarity or difference between sentences in a precise mathematical way. So if we take this sentence, Helsinki has excellent reindeer, I'm sure this is true, and let's assign this the number 1, and then we can calculate exactly how different a sentence like Helsinkians like cinnamon buns is. So this is 0.612 similarity to Helsinki has excellent reindeer. But if you take a completely different sentence, like design is hard, that only has 0.04 similarity to the first sentence. And if you do another one, like angry plastic cowboys, but completely different, is negative 0.034. So you can also have negative difference between things. You are mathematically calculating how far away sentences are from one another in this latent space. This is how we use language models for search engines, right? This is how you are calculating semantic similarity, so that when you ask a query to a system that uses language models, it can calculate the semantic meaning of how similar your results are to the query, which is why they make such good search engines. We can, of course, also use them for next word prediction, aka text generation, or what we've come to know as chatbots. So if you write in a sentence like rubber ducks are, and tell it to fill in the rest, it has percentage calculations of exactly how likely it is that that sentence is completed by rubber ducks are yellow, rubber ducks are small toys, they are used in the bath, right? This prediction ability is how language models are able to answer questions you ask it, because they're just returning a statistically likely answer based on their training data. So this is how tools like ChatGPT can generate text that looks like a very competent, intelligent person wrote it. If I ask it about Kant's position on morality, it gives me a really good answer. We have a bunch of tests and benchmarks that measure how well models can answer these kind of questions, and it's far higher than most humans. Models are even more capable than we think them to be because generating text is only the tip of the iceberg. Chatbots and text inputs are extremely inefficient and indirect ways of exploring latent space. Since creating these models, we've been trying to understand what they're for. We have these capabilities, and we're trying to map them onto real-world human problems. So we're in this strange situation where we've invented a thing, but we don't quite know what to do with it yet. So I've learned a lot about this problem from working on Elicit. This is the product I've been the designer on for the last 2 years. We've built a tool that helps professional full-time researchers, so academics, scientists, civil servants, consultants, search for, review, and analyze thousands of research papers. And we found that language models are extremely good at helping with this specific practical real-world problem. You can get a language model to focus on a single research paper, and it can summarize the content in it quite accurately. It can give you the key points. It can answer questions about the paper, and it can explain like you're 5, which is quite useful for academic papers. Or it can take a large stack of thousands of papers and extract the data into an organized table. This is a process that researchers currently do as part of a literature review process where they have to read thousands and thousands of papers and extract all kinds of very specific data out of it, like the dosage in a study or the number of participants or the outcomes measured. And usually this can take people for anywhere from 6 months to a year doing it manually, reading PDFs, putting it into an Excel spreadsheet. But with tools like Elicit and similar ones, you can do this in days to weeks. So this is what Elicit actually looks like. You type in a question, pretty classic. Here I'm asking, like, how does Ozempic compare to gastric bypass surgery? And it finds all these papers and displays them in a pretty standard table. It's like an Excel document. But then in every single cell, you're able to extract those key items, what they studied, what they found, what the limitations were. So this just speeds up what researchers would do manually otherwise. We also allow people to see the source quotes, so we're always linking back to the original material so you can tell whether it's been hallucinated or not. And we try to point out areas where we have our models try to rank their confidence level in the answer. And if it drops below 90%, we show them a little warning saying, hey, you should double check this answer. Like the model isn't entirely sure this one was right. So we're trying to make this more transparent and accurate for our users. So in working on this product, I've had to think a lot about how to responsibly design interfaces backed by language models, because there are tons of challenges in here about trust and reliability and truthfulness and transparency. And because our users are scientists, they care a lot about those things. And I'll talk more about techniques for that towards the end. But it's been a very challenging task from what we've seen so far, but we also know there's tons of potential in this. There are a lot of very tedious workflows and knowledge tasks and difficult research challenges that humans currently have to do that language models do make faster and easier, which frees us up to do much more important work. Rather than spending 6 months reading thousands of papers, you just move on to actually doing your scientific experiment or running a drug trial. So I have a lot of thoughts, but this is mostly going to be about why language models are this like mysterious, finicky pain in the ass to design with. It's particularly going to be about useful ways to think about language models, about the tension between traditional programming and language models, and how to design models to be tiny, specialized reasoning engines. So back to language models being a pain in the ass. I'm sure we've all heard something along the lines of like ChatGPT lies. This is like, I hear this all the time in user interviews. This is everyone's main concern about language models. And by lies, they see, you know, if you ask ChatGPT something like, what is the world record for crossing the English Channel entirely on foot? It will first say it was 12 hours and 10 minutes by someone named George. And if you ask the question a few minutes later, it tells you it took 6 hours and 57 minutes by someone else. And then a few minutes later, you ask again, and it says it took 10 hours and 57 minutes. So at this point, we know ChatGPT does not know how long it takes to cross the English Channel on foot, particularly because it's a body of water you can't walk across. But we've learned at this point, like, this is it returning what it thinks is statistically the right answer, not necessarily the right answer. This is another classic one where it struggles with maths. If you ask it what 1 + 1 is, it'll get the answer right at first. But if you challenge it and say, well, are you sure that's the right answer? It will just agree with whatever you just said, that like 1 + 1 now equals 3. I love this one from one of my coworkers, was trying to get GPT-4 to give him a horse riding an astronaut, not an astronaut riding a horse. And he got this, and he went, no, I asked for a horse riding an astronaut. And it went, OK, here it is. It just made it more space. And he asked again, and it just made it more space. And this is where you get into, like, models aren't actually giving you the thing that you wanted because they're just doing the most likely thing that it's seen before. So we politely call this phenomenon hallucination, right? This is when language models say things that are not true and accurate to our world, or they fail to give us the thing that we asked for. I like to compare this to like a really smart person on some mild drugs who's like very confused about who they are or where they are, but they have tons of knowledge that you could get out of them if you just asked in the right way. And because it's making predictions based on its training data, right, it doesn't have any access to the real world to check its answers. So this is why this like hallucination is happening. The trouble is that models are simultaneously seem incredibly dumb, but are also incredibly capable. And these are two realities that we are currently trying to reconcile. So this is a chart from the GPT-4 release paper where they tested it on a whole bunch of standardized tests, and it scored incredibly highly. So it got in the 90th percentile on the bar and the SAT, it got in the 88th percentile on the LSAT, and the 99th on the GRE. And these are scores that are incredibly hard for humans to achieve. And even though they're like standardized exams, it still shows that it contains and is able to return the right answer in a vast majority of contexts. GPT-4 even beat out humans on creativity tests, right? Not just on standardized tests where you give the right answer. So this is a study done in the middle of May where they tested 100,000 humans on a bunch of tests for divergent thinking and creative writing. And humans won across almost every other language model, but on GPT-4, everyone scored GPT-4's answers as far more creative and far more original than anything the humans came up with. So I call this like capabilities gaslighting. So gaslighting is when you have someone in your life who's like manipulating you and lying to you and trying to make you believe like your reality is false, which kind of feels like what these models are doing sometimes. It's like they're geniuses who are playing dumb, or they're dumb machines playing geniuses, but we can't tell which one it is. So how are we supposed to think about these models? I find it helpful to think about language models as squishy. So what do I mean by squishy? Right? Language models feel like something organic and biological rather than something mechanical. It feels like we grew them rather than that we built them. And because we don't fully understand how they work, that is very unusual for a creation. Like, it would be very strange for us to build a car and not be able to explain how the wheels turn. But that's the situation we found ourselves in. Language models are often referred to as black boxes because of this lack of understanding and seeing exactly how they're returning answers to us. I also think they're a little bit evolutionary in terms of the fact that they learn by trial and error. So when we train models, we use a process called deep learning, where we give them a goal, and then we score them on how well they achieve the goal. And then we run that loop over and over and over, and they learn through trial and error how to achieve the goal in the way that we want them to. So it's a little bit like evolution in that they're optimizing for a certain outcome in a particular environment, so they're adapting to be successful. They often also have emergent skills and surprising behavior that we don't expect them to have, which is why it makes it hard to predict what they're going to be good at. They're a little bit like a natural phenomena where we need to run lots of experiments on them to learn how they work, a bit like we would with a new virus or a new cell. So AI researchers and ML scientists often talk a lot about language models as like alien minds that we've stumbled across. So this is Andrej Karpathy, who's very famous, co-founded OpenAI, and he called them a very complicated alien artifact. The general consensus is we don't fully understand what we've created. So this metaphor of aliens shows up in articles, it shows up in other people's conference talks. It's kind of become the dominant metaphor for language models among researchers. Oh, refuse to go next. Okay. There's also a second metaphor that's popular, and this is this squishy biological nature has made a lot of people in the AI community start talking about models as creatures, specifically a creature called a Shoggoth. So this has become the unofficial mascot of language models that you might have seen around. So a Shoggoth is a character from H.P. Lovecraft's poems, and he describes them as a massive, amoeba-like creature made out of iridescent black slime with multiple eyes floating on the surface. And the Shoggoth meme has now become a thing that people have picked up to like explain new advances and changes in the way language models are built or architectures are built. And so people keep making different versions. Here's another much more visceral version. And what most of these memes are getting at is they're trying to explain that most of the training data we use to train these models is just this huge, enormous dump that no one has the time or energy to scan or review. So there's all kind of gross stuff in there. It could be like 4chan, like the depths of Reddit. We don't know, because you couldn't actually read all that text. It's impossible. So it's like we have this huge, grotesque monster we've trained it on, but then we put this nice surface layer of pleasantries on top of it, right? So this is the bit where we trained it to like not say anything racist or offensive when it talks to people in ChatGPT, like a nice smiley face on top of what is like a big, scary, unknown thing. So given that these models are these untamed, squishy, biological things, we have a core tension we need to navigate when we're designing and building with them. And this is what I call squish versus structure. We're trying to make an unpredictable and opaque system adhere to our very rigid expectations of how computers behave. So we currently have a mismatch between our old and new mental models for computer systems. Because the selling point of computers up until this point is that they are incredibly predictable, structured, and reliable. They do what you tell them to repeatedly without getting tired or bored or needing a break, way more reliably than a human ever could. Which is why we put them in charge of things that we need to make sure get done, like paying our salaries on time or tracking a patient's vital signs during surgery or controlling traffic. We complain about their occasional failures, but that only emphasizes how much we take for granted, that most of the time they do exactly what we tell them to, millions and millions of times over. No human could actually do this, so we don't want humans doing these incredibly important, reliable things. Because in traditional computer world, right, you press a button, and like a predictable sequence of logic functions runs. And you can see exactly which functions are running. If there's a bug in it, you can track down that bug and eventually fix it. Right? The system is observable and transparent. It's actually super predictable and rigid to a fault. But the thing is, what we're currently doing with language models is we're presenting users with almost the exact same interface, the exact same devices, but instead we're feeding it into this like squishy Shoggoth that returns something that works in a very different way to traditional programming logic. So you might remember Microsoft's Bing chatbot from last year. This is now dead, or it's turned into Gemini or something. So when this chatbot was released, it kind of went down in internet history because it would occasionally reply to people in very romantic and sexual ways, even when they were not driving the conversation in that direction at all. Oh, did I go back one? Sorry. Oh, OK, let's get back caught up. There we go. So someone was just asking normal stuff, and it starts going, you are my best friend and my lover, you are the reason I wake up every morning, you are the reason I go to sleep every night, like really creepy, personal, romantic things. And this was completely novel and unexpected behavior, both for the users of this product and the people who built it, right? They didn't expect it to behave this way. So the problem here is we're using the exact same interface primitives to let users interact with a fundamentally different type of technology, and the expectations are completely mismatched. And predictability is supposed to be a hallmark of good user experience, at least traditionally, right? We want the user to know what to expect and never be faced with results or feedback that seems out of the blue or confusing to them. I think this rule is still true, but we're probably going to have to rethink it as we start to use more generative systems and emergent processes in our work. So in a way, we need to put Shoggoth in a box. We need some predictability and control. We can't just expose normal people to the crazy Shoggoth monster, at least not in its current state. So most of the work around language models is around constraining their behavior with various techniques. Because we're trying to get the best of both worlds, right? This creature is really interesting and it has a lot of potential for creative, open-ended exploration, but we have to figure out how to guide it towards sincerely useful tasks. So we need some way to constrain it. One way that you've probably heard of is prompt engineering, right? This is where you describe exactly what you want out of a model, and then you give it a few examples of what you want, and you tell the model that it's very smart and beautiful and funny, so it gives you the right answer. You can also fine-tune models. So this is when you train it on a smaller data set and you tell it to pay more attention to this data than its larger training data. And then reinforcement learning is when you get humans to score the output and feed that back into the model so it learns what kind of results that you actually want it to give. So our biggest design challenge in designing these models is finding this ideal balance of squish versus structure. It's not one or the other. It's actually a spectrum. So depending on your use case, you might need a product that has more squish in it. So if you're making something for creative writing or for poetry, you're going to want what we call a higher temperature. This is where the amount of randomness that the model returns, so a temperature of 0 is no randomness, and a temperature of 1 or above is quite a lot of randomness. You can also do more or less reinforcement learning. Having no reinforcement learning is called a base model. We don't actually have access to those. That's the sort of thing OpenAI or Anthropic has that they don't release to us. But doing more reinforcement learning on top of that will get you a much more predictable output. You can do more prompt engineering, so giving it highly constrained instructions and very optimized prompts. And so more squish is going to give you more surprise and creativity, and more structure is going to give you more predictable formatting and outputs. For most products, you probably want to be somewhere in the middle. This is like the Goldilocks zone. You don't want full squish, or you don't want full structure. Full structure, you might as well use traditional programming systems, right? Pure logic, pure functions. You can see how it's doing. It'll be cheaper. There's no point in using a language model for those kind of tasks. But too far on the left, things get very weird. For example, this is GPT-4 on, I'm going to turn the temperature up to 2, which is very high. And then I try to ask it a question. I think I ask it what should I read to learn more about architectural history? And the response is, frankly, nonsense. Once it will come back. It sort of starts to say a history of architecture, settings, and ritual, and then just goes into like some random text. Like it doesn't. It's just so far outside the predictive model that it's just returning random characters. So this is very creative, right? But this is not useful creativity. When we talk about creativity as humans, our good kind of creativity is usually like a slight twist on an existing thing, or like a slight divergence from something that we already know and are comfortable with. This is not good creativity. So I've mentioned before like a few ways to solve the Squish structure tension, but there's another way that we specifically focus on a lot at Illicit, and that is making language models compositional and treating them as tiny reasoning engines rather than sources of truth. So compositionality is a kind of fancy word, but it simply means taking large, complex cognitive reasoning tasks and breaking them down into very small, manageable subtasks that we can see the inputs and outputs of. So let's say I want to answer a question, like what are the side effects of magnesium supplements? And this is the sort of thing I could Google in the before times. But now let's say I ask GPT-4, right? And it gives me an answer. It lists like, okay, maybe abdominal cramping and nausea. But the problem is, like, I have no way to validate or debug this answer. I don't know what the source is. I don't know if this is from medical research or from a paper or someone's blog, right? This is like a one input, one output approach. And I have no idea what's happening in the middle, and I cannot validate that this is true. So as a scientist or researcher, this is useless to me. One way to improve this process is to think about what a human would do to answer this question, and then to build an architecture with language models that mimics human processes. So here, if I was a human, I might search Google Scholar or another scientific database that I trust for a bunch of keywords like the side effects of magnesium. And then I would like read the title and abstract of every paper, and then I could get a language model to rank those by semantic relevance to my questions. This is where you're actually using that language calculator piece, not the generator piece. I can then use like traditional programming to do something like filter for number of citations. You're still including it in like all the useful programming we've already built. We're not throwing that out the window here. I can then ask it to generate and ask sub-questions, like how does this relate to gender? How does this relate to dosage? How common are each of these side effects? And then run the same process on each sub-question. And at the end, like summarize all of those into a paragraph. But in this approach, I can run through every single step of this, see its inputs and outputs, and debug the answer if I think that the final answer isn't correct. So you're making it possible to see its reasoning along the way. And this is how we are able to give people answers that are informed by specific scientific papers with source quotes and not like random mystery internet content from the training data. So this approach is also sometimes called prompt chaining, as in like you make chains of many things that add up into a final prompt. You are combining language models with traditional tools like web search, programming, pulling in information from trusted databases that make up for its weaknesses. As a part of this, we can also get language models to engage in some kind of primitive cognition. We can ask it to reflect on its answers, and if it thinks it's valid or true, we can ask different models to critique each other to double check that the answer's right. And then like make plans and execute on those plans. We can also include humans in this loop to redirect the model if it's going off track. So this isn't necessarily all automated. You could have humans interrupt at any moment in here if you're making it visible as you go along. So in each step of this prompt chain, we think about these as tiny reasoning engines. Like you use a language model to do one specific thing very well. You ask it to summarize, to extract data, to find contradictions, to compare and contrast ideas. And then you run those engines over data you trust, right? Over a database of scientific papers, over Wikipedia, over your personal notes. So then you're not relying on its training data as your source of truth. You're relying on a trusted source that you've fed into the model. And then we make sure we always have small, observable inputs and outputs we can check in these systems. So the larger point here is we shouldn't be outsourcing complex reasoning tasks to like crazy Shoggoth models. If you can't see how it reasons, oh, sorry, I keep hitting that wrong. Why would you trust its reasoning? So I've been talking a lot about the technical implementation side of language models, but these principles apply to design too. So I see a lot of products that try to outsource too much cognition, both to the language models and to the users. There are a lot of interfaces like this, where they just present you with like a magic AI box, and they're like, you can ask it anything, like what do you want it to do? Right? And the user has to think, well, like what can it do? Like what should it do? Like what is this thing? for? Because this thing has no affordances, right? There are no knobs or doorknobs for you to grasp onto and do something with this thing. You are essentially offloading all the cognitive labor to the user, and then they have to figure out what it's capable of doing. And then they have to figure out also how to get a good result out of it. You're making them be the prompt engineer and the designer. Because the thing is, it can't actually do everything. Like if I typed in, bring me a large cappuccino in 30 minutes, it wouldn't do it, but it told me it could do anything. So this AI pattern is kind of widespread. Like this is a feature in a very popular note-taking app I won't name, but it's essentially similar to the screen I just showed, right? There are no pre-baked commands you can run. It's all very open-ended, and the user has to figure out like what this thing is for. Instead, I think of making these generic text-based interfaces, we should be designing language model systems that do a set of very specific tasks very well. And I call this that we should make like tiny, sharp, specific tools. Back when I first started working with language models 2 years ago, I mocked up this interface for a writing tool that gives you a set of very specific commands to run, right? Like say more about this, critique this, rephrase this. I think of this as features that are like spell check sized. They do one very specific thing well. And then on the back end, when you have these specific tools, you can optimize your prompts and your infrastructure to make sure the user is going to get a really high quality result. And it's good to see the industry is like moving in this direction. Like earlier this week at WWDC, Apple announced their writing tools that are going to be on Mac OS. And you can see they're all very specific. They're like, make this more professional, make this more concise. This is not an open-ended text box. And then this is another tool that Google made called TextFX, which is more for creative writers like rappers and poets. But it gives you a set of very specific tools, like give me something unexpected or explode this concept. So here I think I've written in, like, give me something unexpected about a dangerous pretzel. And it's like a pretzel that shoots lasers out of the top, or a pretzel that is actually a venomous snake. Like some of them are a bit cliche. But if you're trying to do like poetry or creative writing, these are exactly the kind of like sharp, specific tools you would use, but using your own mind to try to come up with ideas. This just helps move you forward a bit. This is another great example. This is a prototype that my friend Amelia Wattenberger is building. It's a writing tool. She's a writer. So here she's using semantic embeddings to highlight different qualities of the text that she's already written. So here this is showing sentence lengths, like long versus short. And this is showing tones. This is like happy versus sad sentences. She also had ones for like abstract versus concrete. So it's sort of like lenses or layers she can like put over the text to help her decide how to edit or change or make it more engaging. And this is exactly the sort of thing that language models are great at, this like textual analysis. And it's a super practical implementation that is not a chatbot. So to wrap this up, I just want you to walk away having learned that we should think of models as squishy biological creatures, that you should find the Goldilocks zone between structure and squish for your particular use case in products, and that you should treat models as tiny, specialized reasoning engines rather than giant, know-it-all, do-everything products. Trying to make them a universal text box that claims to do everything is like the road to failure, in my opinion. It can't do it well, and it won't. Anyway, thank you very much for listening. If you want to read more of my writing, maggieappleton.com. I'm still on Twitter, @Mappletons. Yeah, thanks. Yeah.